Alright guys, so this is a part two of the series we started. We're talking about how you can calculate RMM. And the part one we talked so much about it already. We did a preamble in the part one of this lecture and we solved about 3 questions. So and I promised to do a part two, which is this right now. So we'll solve 3 more questions on this wise, and you already know how it goes. So if you missed the part one, I vehemently recommend you go back so you can watch that one so you get the dynamics. So because in this part I'll be going straight to the way it is solved. I won't give too many exegesis. So if you missed the part one, I strongly recommend you go back there and watch that one. So for this part, so the first question I will start with is sodium carbonate, Na2CO3. So, like I told you, the first thing to do is that if you look at this, here we have 2 subscripts here. The first is the 2 right, beside sodium, and the second is the 3 right beside, carbon. This 2 you see right beside sodium will only affect sodium. See that now? And this 3 you see right beside oxygen will only affect oxygen. So it means it will not affect carbon. It will only affect carbon if this were a bracket, but it is not. So realistically, it will only affect oxygen. Now let's bring out our stuff. Here, sodium, is 23 times the 2 we talked about here. Then plus, because we're adding them together, the mass number for carbon is of course 12, and the mass number for oxygen is of course 16. Now we're going to do 16 times the 3 we talked about here, and if you do that, 23 times 2 gives you 46, then plus 12 from carbon, then 16 times 3 gives you 48. So if you plus all those together, you should get 106 grams. So this is the relative molecular mass for sodium carbonate. Now, next, let's talk about this one. This is copper sulfate, but the IUPAC name is copper 2 tetraoxosulfate 6. So when you're writing your external exams, it is important you know the IUPAC names. And just to mention, for those of you writing, IUPAC stands for International Union of Pure and Applied Chemistry. So it means IUPAC names of inorganic compounds are very important, and this is one of such, because in most of your exams you'll be required to use the IUPAC name instead. Now, copper, there's no number beside copper, so copper has this subscript here. Then we have sulfur, and of course the 4 we have here, like I told you, we affect only oxygen. Why is it so? Because the 4 is not outside of a bracket, it is only in front of oxygen, so it means it affects oxygen only. Now, getting back to work, so we have copper. The mass number for copper is 63.5 or 64. But I want to use 64 so to avoid some annoying decimals. Now we're going to add that to sulfur. The atomic number for sulfur is 16, but the mass number is 32. Now for oxygen, like you already know, the atomic number is 8, but the mass number is 16. And we're going to do 16 times 4 because we have a 4 attached there. So that is 16 times 4. So if you do this, you have 64 here plus 32, and then 16 times 4 gives you 64. So if you sum this up, you should get 160 grams. 160 grams. Alright, so that is it for that. And number 3, which will be the last, let's talk about this one, C2H5OH. Now, from organic chemistry, this compound is what we call ethanol. So it means If you're familiar with organic chemistry, you should know about this. And if you're a newbie to organic chemistry, this is ethanol, and ethanol is an alcohol. So that is it. But that's not my point of emphasis here. My point of emphasis here is to calculate the relative molecular mass. Now, if you look at this, here is a little bit more sophisticated than the others because we have numbers attached to two of them. So carbon, we have a 2 here, and this 2 will affect only carbon. Then you see hydrogen, we have a 5 here, that will affect only hydrogen. For here, there are no numbers for oxygen and then for hydrogen. Now, let's begin with carbon. Carbon has a mass number of 12, like you already know. So we're going to do 12 times the 2 it has attached. That will be 12 times 2 plus hydrogen has a mass number of 1. But we have a 5 beside hydrogen there, and that gives us 1 times 5 plus oxygen has a mass number of 16, of course. Then we add that up again. Then we have hydrogen here, which has a mass number of 1. So if we do this, 12 times 2 gives us 24, plus 1 times 5 gives us 5, plus 16 plus 1 gives us 17. So 24 plus 5, that gives me 29 plus 17. So what is 29 plus 17? Easy, you don't have to use a calculator. So do 29 plus 10, that gives you 39. 39 plus 7, that gives you 40, and that is 46. So this is 46 grams. Alright guys, that is it for this particular video. I believe you enjoyed it. Do not forget to leave a like and a comment, of course, and share the video with your friends who will find it helpful as well. And if you are new to the channel, please consider subscribing because I upload videos here 5 days in a week. That is from Monday till Fridays every single week.